All right, here we go, boys and girls. What we are going to be talking about now is this Unit 4, which the key idea behind this is a thing called linear aggression, which is broken down into several key categories of the least squares line, the correlation coefficient, and the coefficient of determination. All of these formulas are the formulas for these key items. Now, before we begin, I very much highly encourage you to download this calculator. It isn't very downloadable on the Chromebooks that the school provided. However, you may want to get to a personal computer of some sort. So again, like for instance, I'm using my personal Dell computer. And if you use your own personal device, you're able to download this emulator and use this just fine. But without this type of calculator, this is going to be pretty difficult. I mean, it's not impossible, but it's really more difficult than what I really want to get to in this video. So if you can, take a moment and get this calculator or get on a computer that can support this emulator right here for our Casio calculator. All right, beginning. What the whole idea behind this whole thing is this. We have, in essence, this XY table, which provides you with a scatter plot of some sort. So if I take these ideas and I plot these concepts right here, I will come up with a scatter plot that looks like something like that or something like that. And so what we are going to be doing is we are going to be constructing a mathematically perfect line of best fit. So if I take a look at this, and I'll make this purple or something, and I make a mathematically perfect line of best fit, what we can do is we can tell a few different things. So the first question is, what is the sample correlation coefficient? And that question is asking, how good is this line? Yes, I know it's perfect, but even though it's perfect, how good is it? And I see, oh, if this is the information, I see that these dots stray from this line a bit, so it may not be absolutely perfect, as in like all of the dots are exactly on this line. So this is on a scale of 0 to 1, 0 being awful, 1 being absolutely perfect, like all of the dots are on the line kind of perfect. So if this were the case, I don't know, this would have a correlation coefficient of 0.7, saying, oh, it's really good, but it's not perfect. It's better than good than bad. Also, it can be negative. And what that would mean is if the correlation goes downhill, then it just goes downhill. But again, it's still on a 0 to 1 scale as far as the correlation coefficient is concerned. Okay, so this correlation coefficient would be positive, and I would guesstimate it to be right around 0.7 or so. Okay, now, it's all fine and dandy to just kind of guess what this line is, but again, mathematically perfect, there is an equation of this line. And that equation is right here. It's the least squares line. So this will give you a line which has a y-intercept and a slope, and that will give you the equation of this line. Coefficient of determination, we'll get to. Coefficient of determination is pretty much this next question, just kind of changed a little bit, is as a what percentage of the variation of y can be explained as x. So like if I say, oh, if I say 50, if I say the number of hours trained was 50 hours, what does that variation actually mean as far as y is concerned? Like how much, what percentage of it is affected? And then we're going to make a prediction using this equation that we've made. Okay, first things first. The sample correlation coefficient. So that is, how good is this line? And again, that is the value of R. So I'm going to use my calculator to figure this out, and I'm going to set this up in my stats screen. So these are going to be my list ones, my X's are going to be on my list ones, Y's are going to be list 2. So away we go. Okay, so I have the X's and Y's listed. Now, we can make the Christmas tree and we can go through all sorts of calculations, but again, there's a way quicker way of getting this first calculation, which is the correlation coefficient R. Where we look on here is we calculate reg for regression. Okay, this is going to be a linear regression, so this is going to be an X regression as opposed to like a parabolic or a quartic or, excuse me, like any of these. So this is going to be a linear. Linears are X's. Boom. Okay. So this tells me a whole bunch of information. Let me jot a lot of this stuff down. First and foremost, I'll answer this question, what is R? Okay, so the sample correlation coefficient R is given right here is 0.7610. Okay, rounding 4 decimal places. Okay, that is this regression. Now, other things. Now, I'll get to the second piece here in just a sec, but notice that. Actually, I'll get right to it right now. Okay, this is going to be, we're looking for something that is y hat, I can't really make a hat right now, y hat is equal to a plus bx. But take a look at what they have it as. They have it as y is equal to ax plus b. All right, so this a, the one that's next to the x, is actually my b. Their b is actually my a. So these are the correct numbers. It's just that they're backwards. So reading this a little bit differently, what I have my A as is, again, being their B. And their B is 85.5300. My B, aka their A, okay, this E moves the decimal place 3 places to the left, so that'd be 1 and then 2 zeros. So that would be 0.0, as you were, 0.0083. 0.0083. Okay, so again, this A and B is opposite of this A and B. Okay, calculator is exactly opposite of what you want. All right, on to this equation. So y hat is equal to A plus B x. A plus bx. So again, this is y hat y hat. This being an equal sign is a little confusing, so I'll turn it into an implies. Okay, so y hat is equal to a plus bx implies, putting in my numbers, y hat is equal to 85.5300 plus 0.0083x. Okay. Next is the value of the coefficient of determination. Coefficient of determination is r squared, and they straight up say what it is. It's just this number squared, but they already did all the dirty work for you. So that's 0.5791. All right. The percentage of y that can be explained as x. Well, what this number is, this percentage, is just this coefficient of determination written as a percentage. So we move this decimal place 2 places. So the decimal place is going to be moved right there. And now this is a percentage. So 57.91%. This is supposed to be r squared. I'm sorry. Okay. Okay, so that gets us through the majority of these problems right here. Last but not least is the prediction that we're asked to be being made. And where this prediction comes from is our equation which is right here. So what we're going to do is we're going to take this equation, and then we're just going to input the information that we have. All right, so a good thing to understand is what kind of information did they just give us? So they gave us hours trained being 500. So we take a look at, well, what the heck is that? Is that an X or a Y? And we see that the hours trained, okay, is an X. So where are we going to put this 500? We're going to put this 500 very specifically in for X. Okay, it's supposed to be an arrow, but that's going to go in for the X. Now, if they would have asked, well, how many hours do you need to train if you want to throw 125 feet? Well, if they would have said 125 feet, that would have been a Y. So you'd put it in the Y, and then you would solve for X. But anyways, in this situation, we are given 500 hours, that being the hours trained. That is very specifically the X. So I'll show this as best as I can. So what we're doing is we're taking this, but we are taking this X and we are turning it into 500. So to my calculator, I can just go ahead and type this in, 5300 plus 0.0083, 500. There it is. So my prediction, according to my least squares line, is 89.68. This is in feet. So if you were to train 500 hours, how far would you expect to be able to throw a discus? You would expect to be able to throw a discus 89.68 feet. So that's where 500 would kind of get you. Okay, so it's a little bit different than what the table kind of implies. But that's what it is. All right, so the assignment, again, is back here. You're asked to answer pretty much all the same kind of questions as up front here. Again, try to get this calculator right here. If you don't have this calculator, this is going to be very difficult for you to accomplish. Get this emulator from my Google Classroom as long as you have your own personal computer, because it doesn't work very well on the Chromebooks. So try to borrow a computer or get something that you can personally own and you have download capabilities on it that you can like store things. All right. Again, this is the unit for CRT prep.